Example 3, find the equation for x to make the parametric equation complete. So here we are, we're given this rectangular equation here, and we're given this piece of the parametric equation. And this part is the parametric because it has the t. So what we're going to do is, remember our steps is first, we always solve for what is shared, or we can solve for the trig and sometimes. So I'm going to say solve for what is shared, which in this case, it's the y. So typically we would solve for y here, but and the way we could do this is one of two ways. We've already solved for what is shared, so we can go straight into substitution, which is the second step. And there's really two ways of doing this. One is you can see that, oh, this is y minus 1. I could make this y minus 1 by subtracting 1 from both sides. But to keep my steps consistent, I'm not going to do that. Since I already have what's the y, that's what's shared. Since I already have that, I'm just going to plug that in right here. So I would have x squared plus, and instead of the y, I'm going to replace it with 3 cosine t plus 1. Now this, technically, when you ever substitute, needs to be in parentheses. So it's substitute that in for y, and then I have the minus 1 here, squared, and all this equals 9. Now, within this parentheses that I added, you can see that nothing happened. So I could take that away. And so really what I have is 3 cosine plus 1 minus 1. Plus 1, the minus 1 will go away. So I have x squared plus 3 cosine t, and now this needs to all be squared, equals 9. Now we need to get x by itself, so I'm going to first, let's just make this easier. 3 cosine times 3 cosine, which means 3 cosine squared, is the same thing as 9 cosine squared t equals 9. To solve for x, because that's what I need to do, find the equation for x, I'm going to move this over. The way to do so is we would subtract the 9 cosine squared t from both sides. When I do that, this goes away, and I have x squared equals 9 minus 9 cosine squared t. Now you may remember from the previous example, anytime we have a trig, we're going to end up using the formula, the Pythagorean identity from the formula chart, which was that sine squared theta plus cosine squared theta equals 1. Well, in this particular case, what I'm going to actually do is I'm going to rewrite this. I'm going to show you that sine squared theta is the same thing as 1 minus cosine squared theta. Now, how did I get that? I just move this to this side. So sine squared is equal to 1 minus cosine squared. Now, why does that come into play? Well, check this out. If I rewrite this as x squared equals 9, I'm going to do a GCF here. Greatest common factor. 9 is shared in both, so if I divide it out, I'm left with 1 minus cosine squared t. From here, I can substitute in for sine squared. So this is going to become right here sine squared. And so x squared equals 9 sine squared t. And the last thing to get x by itself is you take a square root. Now when you take a square root, technically speaking, we should have a plus or minus 3 sine squared t, because either one of them should work. So this would be my answer here. And now let's go check a graph to make sure it works. So I'm going to start with the original. We're going to go to calculator, and I'm going to go to graph here. And it gave it to me as a rectangular equation, and it was a circle. It was in the circle form, just like this. And there was no number with x, but we had y minus 1 squared, and it was equal to 9, which is the same thing as 3, or you could just do square root 9. Let's double check and make sure I got this equation right. There was nothing with the x. It was y minus 1 is equal to 9. So I have that. I press enter, and I see the circle that I'm supposed to have. Now we think we've come up with the answer for the parametric. So I go to menu, graph entry, parametric, and we think it's this value. Now I'll first do the positive for the x, which was 3 sine squared. Whoops, I didn't realize I did this. Look, when we took the square root, that should not be squared anymore. I'm so sorry about that. That should just be a t. So y'all were probably watching this wondering what I was doing, but I was just checking to make sure you're paying attention. So we should have 3 sine t, 3 sine t. And then our other equation was, let's go back up and look at it, 3 cosine t plus 1. 3 trig cosine t plus 1. Press enter and see we get the same exact graph. Now, let's say, what if I would have had that negative? Because remember how we said it was plus or minus? So let's go back up and say, what if this was negative? Would it still work if I made this -3? We'll check it. So put a negative there, hit enter. Notice it's still the same graph. So either way is right, and that's why we need that plus or minus on there. All that would do is change the direction of the graph, the orientation. Or rather, not even the orientation. What it would do is it would change this beginning location.